So good day everyone, I am Teacher Hennessy and we will be talking about nano manufacturing, scaled up, reliable and cost-effective manufacturing of nanoscale materials, structures, devices and systems. It includes research, improvement and new processes for creating materials at the nano level. It involves improvement, research, and incorporation of new processes. So scientists continually study new ways to create nanomaterials because the field is always evolving. Better tools and methods are developed to improve precision and efficiency. So next, approaches to nano manufacturing. We have two approaches of nano manufacturing: bottom-up fabrication and top-down fabrication. So bottom-up fabrication builds products starting from atoms and molecules, time-consuming but highly precise. So this means that this method constructs materials at the same way nature does, beginning with very tiny units that join together to form larger structures. So, time-consuming but highly precise. Since assembling happens atom by atom, the process is slow, but it results in a very accurate and highly structured and high quality structures. So, while the top-down fabrication trims or cuts large materials into nanoscale pieces, uses more raw materials and creates waste. So this means that a bigger material is shaped into nanoscale dimensions using tools such as lasers, etching machines, or milling devices. And also, it works similarly to sculpting, removing parts of the material until only the nano-sized portion remain. There are new approaches to the assembly of nanomaterials based from the application of principles in the top-down and bottom fabrication. These includes the dip pen lithography. Uses the tip of an atomic force microscope dipped in chemicals to write on surfaces. It is the microscope's tip acts like a pen and deposits chemicals in a very fine lines, forming nanoscale patterns. So the next one, we have self-assembly. Components automatically arranged into organized structures. So molecules position themselves due to natural forces, forming patterns without external control. So this is what we call self-assembly. Next, we have the chemical vapor deposition, or the CVD. Chemicals react and deposit thin, pure films on surfaces. So gas chemicals are heated until they form solid layers on materials like metals or silicones. So SVD is essentially used for making chips, solar cells, and productive coatings. So next we have nano-imprint lithography. Stamps nanoscale patterns onto surfaces. So a patterned mold presses onto material to create a tiny shapes instantly, similar to stamping ink. So next one, we have the molecular beam epitaxy. Deposits extremely controlled thin films. So atoms are evaporated into beams and settle onto a heated material, creating uniform and atomic layers. Like microchips, LEDs, and lasers require this high of accuracy. So next one, we have roll-to-roll processing. Produces nanoscale devices on long, ultra-thin rolls of a plastic or metal. So a continuous sheet of material passes through machines and receives nano patterns or coatings. Last one, we have the atomic layer epitaxy. Lays down materials one atomic layer at a time. So each layer is added slowly and evenly. So last one, we have the atomic layer epitaxy. Lays down materials one atomic layer at a time. So each layer is added slowly and evenly, ensuring perfect uniformity. This is ideal for microchips, batteries, and optical devices where thickness must be exact. So, produces materials that are stronger, lighter, water-repellent, UV-resistant, scratch-proof, conductive, antimicrobial, and self-cleaning. So nanomaterials improve physical, chemical, and mechanical properties, making items last longer and perform better. Used in tennis rackets, baseball bats, oil purification, toxin detection, and more. So nano-enhanced products appear in sports, industry, and health. Now, the future possibilities of the nanomaterials are faster, smaller, energy efficient, computers, tiny chips with huge memory, and high-efficiency batteries and solar cells. And that's all for my part. Thank you so much.
Alright, good morning class. I am teacher Cassandra Lane Calasang, and today we will be tackling about the distinct features of nanoscale. So nanotechnology operates at extremely small dimension, typically 1 to 100 nanometers. At this scale, materials behave very differently compared to their larger forms. So now these differences allow scientists to create new tools, medicines, and technologies. Alright, now that we know nanotechnology works at very incredibly tiny scale, between 1 to 100 nanometers, let's explore why this is so important. So one of the most fascinating aspects of the nanoscale is the scale at which biology occurs. So many important biological processes occur at the nanoscale. DNA is about 2 nanometers in diameter. Hemoglobin, the molecule that carries oxygen in blood, is about 5.5 nanometers. So, because biological molecules are nanonized, nanotechnology can interact with them more precisely, and this leads to more accurate medical treatments, improved diagnostic tools, and minimal damage to healthy cells. So one of the best examples here is the biobarcode assay. So a biobarcode assay is a highly sensitive test used to detect very tiny amounts of biological substance, such as proteins, viruses, and disease markers. So it works like a barcode reader for disease, even when the disease markers are too small or too few to be detected by normal laboratory tests. So next, we have the distinct features of nanoscale. Quantum effects dominate. So means their behavior and properties change because electrons move differently at small sizes. So now at 1 to 100 nanometers, materials show quantum effects. At nanoscale, materials show changes in chemical reactivity, fluorescence, electric conductivity, magnetism, melting point, and permeability. So at the nanoscale, gold particles are so small that they interact with light differently. So this causes gold to appear red, purple, or even blue instead of yellow. So these color changes is one of the most famous examples of the quantum effects of nanotechnology. So nanoscale is widely used in medicine, especially in use to detect tumors, used in targeted cancer treatment, and helps in drug delivery by attaching the medicines. And last but not the least, we have the largest surface area. So nanoscale materials have extremely large surface area compared to their mass. So nga may importante naman siya. Why is it important? So meaning more surface area, na siya more contact with other materials. If na siya contact with other materials, na siya higher reactivity. And if there are higher reactivity, we have better performance in catalyst, medicine delivery, and energy storage batteries. So why understanding nanoscale matters? Because it is more effective medicines. We have stronger and lighter materials, we have faster and smaller electronics, and advanced disease detection methods. So in conclusion, at nanoscale materials act differently from what we see in normal sizes. They can work closely with tiny biological, and this helps us make better medicines, faster electronics, and useful new technologies. And that's all for my part. Thank you so much.